Hey, so we're going to continue on with our notes. We're going to do climate today. Okay. So climate is totally different than weather. Okay. Climate is going to be the long-term weather patterns of an area. Weather is that today we can have cold weather, and by this afternoon we can have hot weather. Climate though is what is our climate for that particular area. Usually our climate doesn't go, it ranges between certain temperatures. Um, Climatology is the study of the Earth's climate and the factors from past, present, and future that can make climatic changes. So, climate describes annual variations. So, the temperature, our annual climate, what is the average climate like during here, during the summer? We have an average between 80 and 100 degrees, right? That is an average. Not saying one day we won't have a 60-degree summer day. Um, but climate is also how much rain or precipitation we get, the wind, and all the weather factors. So, studies of the climate show extreme fluctuations of these variables over time. So, over time, these can be very extreme, but for the most part, it stays the same. So climate though, the data used to describe an area's climate is includes daily high and low temperatures. If you ever seen on the news it says, hey, today is this is the hottest it's been since 1976 because we keep an average of the high and low temperatures. So that is going to be climate as well as the rainfall, the wind speed, the humidity, and air pressure. Next time you watch the news and they actually have all those numbers are actually dealing with the levels of climate for our region. Um, the normals and standard values for our location is basically off a monthly or annual basis, period, for at least 30 years. So again, that's why they're able to compare, hey, 1970 on this date, it was 95 degrees outside. But right now it's 70 degrees outside. What happens is we're able to look over time, but most of the time it's going to stay around the same. Our climates really don't differ too much. They can go to the extreme. Weather conditions on any given day differently than normal because our weather today can be rainy and be 20 degrees outside, but then tomorrow it can be 80 degrees with no wind and we have a sunlight. So normals apply only on the specific place where the meteorological data is collected, not the regions. So wherever it's collected at, not just based off a region, not just saying, hey, North Carolina, we're going to be at 50 degrees today. No, because the mountains have a different temperature than it does in here in Rayford. So what causes climate? Well, there's a few things that causes climate. Latitudes, so where you're located at on a map. Topography, how many hills, and if you stay on a mountain or if you stay near the water. The more you stay near water, lakes, ponds, and stuff, your actual climate and your particular area is going to be different. The availability of moisture, so if you're in a dry area or you're in a more wet area, the patterns of the winds, the ocean currents, and air masses, all those things are taken into consideration to develop climate. So here's just the one. Here's a climate for this isn't a old map, but if you look at this map, you can realize that this particular area of the United States in Wichita, 37 degrees north, January 1st, it was about -1 degree Celsius, but by July, it was 27 degrees Celsius. So we can see the average climate. But then if you look at just different regions, so look at San Francisco, 37 degrees north, their climate is higher in January than it is in Wichita. But in July, its climate is lower. So depending on the location of where you at, what you're nearby, the air, if you buy water or you buy drier areas, your climate changes basis off that. So then we also, of course, have latitude. So remember, the latitude is the solar radiation received by one place because of the Earth's tilted on its axis, and it basically affects how much sun rays strikes the Earth's surface. So of course we have our longitude of latitude. So we have the Tropic of Cancer, we have the equator, we have the Tropic of Capricorn. Of course, these is 23.5, but then we also have different ones. We have polar zones as well. Okay, so the amount of sun that hits at these points of latitude actually would determine the area and the climate. Obviously, it's going to be more hotter here near the equator. So let's talk about the tropics. So the tropics is between 23.5 degrees south of the equator and north of the equator. So that is here. So this is your tropics of Cancer and Tropic of Capricorn. Okay, the temperate zones lies between 23.5 degrees and 66.5 degrees north and south of the equator. So this is the area between here. So that's our temperate zones, which is what you see as in green. And then our polar zone obviously is the blue, and this is going to be anything that is 66.5 north or south of the equator. So topographic effects, which is again large bodies of water that actually can affect the climates, especially in the coastal areas, because when water heats up and cools down slowly than land. Okay, so if you ever went to the beach and you got in the water and the water was super cold, but then the sand was scorching hot, it's because again water heats up and cools down more slowly than land. So it's faster than how land does it. Mountain climates are totally different because they're usually cooler than those at sea level because the temperatures are in a lower atmosphere because the atmosphere decreases with the altitude. So the higher it goes up, the cooler it is, not the hotter. Okay. Because most of the time if you see cartoons, what's on top of a mountain? Snow. But down here, it's literally hot. Climate's different actually on either side of the mountain because we may have a lot of sun that hits this side, but on this side, it never gets any sun. So those things are factors. Air masses. So two of the main causes of weather are in the movement, interaction of the air masses. Okay, so air masses affect climate as they have a distinct regions caused by the amount of solar radiation. Okay, so the regions, every region doesn't get the same amount of sunlight. Again, here in Rayford, it could be 80 degrees, but in Fayetteville, it might be 87. We are in two different regions, and we have different amount of sun rays. Average weather conditions in and near regions of air mass formations are very similar to those exhibited by the air masses themselves. So how do we classify this? How do we really understand this? Well, it's going to be on the Köppen's classification system. You have to know this. I'm putting a star here, okay? This right here takes into account of temperature, it takes precipitation, and it takes the vegetation that is found in those areas. So the vegetation is the plants. So the Köppen decided that a good way to distinguish among the climate zones will be the natural vegetation. So obviously, if we have good different types of grass, different trees, different bushes, and how those grows in different seasons, we can actually determine the climate zone. He also provides a system to include numerical values of temperature and precipitation for a more scientific approach. So, but there's 6 divisions: there's tropics, mild, dry, continental, polar, and higher elevation climates. So right here, this is just a picture of the worldwide climate zones using the Köppen classification system. So if you notice, we live here. We have a brown area. So that right there says the best color I think that can go to is around here with a dry winter, and as well as the CFA humid subtropics, right? This is how we can figure out where what the temperatures will be, or guessing by our climates. So let's talk about the first one. The very first one we're going to talk about is the tropical climates. Constant high temperatures. So this is your rainforests, your monsoons, and savanna. Obviously, savanna. we're talking about hotter places. The tropical areas here, they can actually get up to 600 centimeters of rain each year. That's a lot of rain, a lot of rain. So tropical rainforests obviously get a lot of rain, and it has the word tropics in it. The transition zones that border in the rainy tropics north and south of the equator, known as tropical wet and tropical dry zones, because in winter seasons, it can influx of dry continental air masses. So in the winter, they may not get a lot of rain. It may be a lot of dry area. So now let's get to the dry, since we're talking about dry. Being dry makes about 30% of the Earth's land area. Um, Within this classification, there's two types. We have deserts and we have semi-arid regions, or steppes. And so what happens here is that we have air that dominates, but the precipitation is low, so there's not a lot of rain. You're not going to go and see a lot of rain in like Arizona. You're not going to see a lot of it in like New Mexico. You're not going to see a lot of rain in Iraq, in Iran. The vegetation is scarce. If you go over there, you're not going to see it. You've seen pictures of people in Iraq. You just see a lot of dust and dirt. You don't see a lot of flowers, and you don't see a lot of trees. What happens here again is a moisture deficit. And steeps are more humid than deserts, but again, they can border wet climates though. All right. So temperate climates. This is what we call level C. Temperate is based off of three subtopics. So humid, subtropical, marine, west coast, and Mediterranean. So humid subtropical are influenced by high pressure systems, so that are normally found over oceans in the summer. Dominated with inland flow from the ocean. So this is dealing more with the coastal. We are now around a lot of water. Mediterranean is actually by again the Mediterranean Sea, which is generally warm. So this is warmer weather, but it has a little moisture in it because it is by water. Continental. This is level D. Continental is going to give you warm summer, cool summers, subarctic climates. Basically here, summer and winter temperatures can be extreme. Uh, Summers are generally wetter than winter. So instead of having a dry summer, you have a wet summer and a dry winter, especially in latitudes that are closest to the tropics. So remember the tropics, we have the Tropic of Capricorn, Tropic of Cancer. So the more we get down to 23.5, this is going to be the temperatures that you would expect with the continental clients. For us, we do have sometimes some rainy summers, and we have some really, really dry winters. Is because of where our location is. Polar climates, obviously, we're not here. Okay, we were more continental. This is level E. This is going to be your coldest region. This is your tundras and your ice caps. Of course, mean temperature, the warmest month is less than 10 degrees Celsius. That's super, super cold. Precipitation is really low because the air is holds less moisture than the warm air, so it's not enough heat to kind of keep producing those convection currents to keep everything heated up. And so this is found at higher elevations. So top of I'm talking about like going to the North Pole and South Pole. These are the polar climates. It's very cold. Microclimate. So a microclimate is localized climate that differs from main regional areas. So an example here is what shows temperatures in Washington. The buildings and surfaces all have different temperatures. So if you look here, this is a negative 0.6, but then the farther you get away from here, now this is all still in Washington, D.C., you get right here 1.1, 1.7, 2.2, and then we can go as far as 3.9. You go around, you notice that the farther you get from the center, the more negative it came. Okay. So what we also call this is urban heat islands. Urban heat island is a metropolitan area, which is a more rural city, is warmer than the surroundings due to human activity. So of course, when you have a car running, you have buildings going, it's going to be warmer than it is, and you sit in the country like in Rayford, because we don't have nothing running like that. We just have trees and birds. But when we have buildings and cars and factories running, it's going to be a little bit warmer. The result of this is a replacement of trees and other place vegetation, and they build roads, buildings, and heat absorbing infrastructure. Air conditioning is going on. Manufacturing, transportation, human activities discharges heat into the urban environments. Because of the high activity, this is what we call urban heat islands. Not an actual island, but this is what we call it. So what happens again, then we talked about, this is the same example from the DC. The heat island area we can spark convection currents and increase precipitation in the cities. So that's why sometimes you can just have a lot of days it's raining because it was so much heat released into the atmosphere and it gave a climatic change. So these differences are showing daytime temperatures versus this is a urban and this is more suburban. And the coolest are represented by the blue. If you notice, the warmest are represented by the red. This is just a big urban city, and it's mostly red compared to a more suburban going into a country setting. And then now look at this picture. So temperatures and stuff do change. So if you're in a more rural area, from according to this, it could be like 85 degrees. But once time you get downtown, because of all the movement, it could be 92 degrees. So this is why your temperatures and stuff can change just by your location, even though you're not that far from the location. The climates and stuff are based off of these. And they fluctuate again based on the activity.